Hello, this is Mr. Stansbury. I'm going to take you through the notes on statistical hypothesis. At the end of this, you should be able to say, I can write both null hypothesis and alternate hypothesis for a claim. All right, so first thing, a statistical hypothesis is a statement about the nature of a population. Okay, what that means here is, for example, a deodorant manufacturer claims that their deodorant lasts longer than 10 hours, longer than the 10 hours of the average deodorant. This is a statistical hypothesis right here. So they're making a claim. Okay. Hypothesis tests is a formal procedure to help decide whether a statistical hypothesis is reasonable or justified. Okay. I wouldn't necessarily say it's super important that you write all of this down word for word. You just kind of want to get the idea of this here. Okay. So there are three components, and the reason why I'm saying not to worry about writing this down is we're going to go over these three components in several different examples in the upcoming sections, which will should help out a lot. Okay. There are three components: formulating a statistical hypothesis, collecting data from a sample and calculating statistics to test our hypothesis, and then making decisions about the population based on what we see in the sample. Okay, so there's several ways that we're going to test this in the upcoming sections, not in this section, but in ones that are coming up. Okay. Null hypothesis is there is no change in the population. So null hypothesis is always represented with HO, H sub O. Okay, and then this little funny looking thing is mu, which is the population mean, so it's the average. Okay, and then this mu O is the original population mean. Okay, and this will make more sense as we get rolling along here. The alternate hypothesis is that there is a change in the population. So H1 states that the mean is going to be different than the original population mean. So they should be pretty close to the same, and they're going to be different. Okay. There's a thing called a one-tailed hypothesis, where where you can say like the mean is going to be greater than the the original population mean, or that the mean is going to be smaller than the original population mean. So that's basically like you get like these things here, and then m is greater than should be this section here, and then m is less than is going to be this section in here. Okay, and then there's also a thing called a two-tailed hypothesis. So it could mean that the mean is greater or less than the original population mean. So that would basically be something like this, where it could be one side or the other. You find both. Okay, so it's called one-tailed, and so because there's only one side you're checking, or two-tailed because you're checking two sides. Okay. Okay. For this example here, back on the Stank Stop deodorant thing here, the manufacturer wants evidence that the product lasts longer than the 10 hours. So the hypothesis would be, null hypothesis, is that it's going to last 10 hours, which is the average of everyone else. But they want to show that theirs is different. So they would say that their H1, their alternate hypothesis, is going to be that their mean is greater than 10 hours. Their product lasts longer than the average deodorant versus their product lasts as long as the average deodorant. Okay, so that's what they would want to check. Okay. Okay, we got one more example to look at, but let's take a quick comedy break. Okay. A water supplier has chosen a new bottler and wants to check to make sure that the bottles contain 12 ounces of water, no more, no less. What set of hypotheses should be considered? So for our HO, okay, we should have that our mean should be 12 ounces of water. Okay, so the mean ounces per bottle is 12. So our alternate hypothesis should be that the mean does not equal 12 ounces. Oops. Okay. So the mean ounces per bottle is not 12. Okay? Okay. That's all there really is here for a statistical hypothesis. If you have any questions at all, please feel free to ask. Thanks.